Hi, I'm Yogesh Kumar from Ideas Design Solutions. Let's discuss the FEA analysis process using SolidWorks simulation and how to use Trend Tracker feature to analyze the nature of the study created. The Trend Tracker feature helps us to detect trends in results from different iterations of a static study. You can also compare the results of subsequent iterations with a baseline. There are several benefits of using the Trend Tracker feature, some of them are listed here. Now, let's see a demo of how to use the Trend Tracker feature. For that, we will first open our part file. Here we have a metal frame. In this study, we will try to analyze the rigidity of the frame by increasing the load in steps. Force will be applied on the center of the top face. You can create a split face by using split line feature. Now enable the simulation add-in. The process of analyzing designs consists of the same basic steps, regardless of the type of analysis or model. First, a study is created. A material is applied to the model, which contains the physical information such as the yield strength of the model. Fixtures are applied to the model, which represent the way the physical product is held. Loads are applied to the model to represent the forces that cause the part to deform. For our first test case, we will apply 200 kg force on the split face. Now we will proceed to create the mesh. A mesh breaks down the model into a collection of small, simple elements. This allows the solver to find values such as the stress and displacement at each point where the elements join together. Adjust the refinement slider to create a partially fine mesh. Click on OK. Now the software will create a discretized model that will be used by the solver to run the study. Once all of the previous steps are complete, the study can be run to calculate the results. Before running the solver, we will enable the Trend Tracker feature by right-clicking on the top component of the study tree and selecting Trend Tracker. Now run the study. Once the solver terminates, it will ask you for confirmation to save the model. Click on Yes. Finally, the results are displayed in graphical plots according to the result type such as stress or displacement. The current results are shown with a deformation scale of more than 4. We can see that the maximum von Mises stress generated in the body is around 1865 megapascals, which is well above the yield strength of the part. To view the point with maximum or minimum stress, right-click on the Stress 1 plot, select Edit Definition. We can also change the deformation scale to true scale. To view the elements of mesh, click on Settings. Then change the boundary options to Mesh. Now go to Chart Options and enable the Show Minimum or Maximum Annotation checkbox. Now as we click on the green tick, the deformation scale will automatically change to 1. Now do the same procedure with Displacement 1 plot. Here we will also change the display style of the values on the legend to general to easily interpret the deformation results. To view the animation, right-click on the plot and select Animate. Adjust the slider to get the right speed. Now to view the effect of increasing the mesh density on the results, remesh the part with the slider set at Fine. Now run the study again. Save the results. Now we will analyze the change in stress results due to increasing mesh density by clicking the stress to plot under trend tracker header. Notice the increase in the stress values as the iteration changes. Now to see the effect of increasing load on the frame, edit the force definition. Change the value to 400. Now again run the solver. Save the results. Open the stress to plot. Notice the spike in the stress value when the iteration changes from 2 to 3. You can also enable trend tracker for various other type of plots like FOS plot or strain plot. This completes the demonstration of trend tracker. For more information about SolidWorks, visit our website.